Hi boys and girls, welcome to my YouTube channel. Please don't forget to subscribe, share and like this video so that you can receive the latest information. So in today's class we are going to tackle Millman's theorem. Millman's theorem states that a circuit with several voltage sources in series with admittances can be replaced with an equivalent circuit consisting of a single voltage source in series with a resistance. Okay, it states that a circuit with several voltage sources in series with admittances can be replaced with an equivalent circuit consisting of a single voltage source in series with a resistance. Let's say you have a circuit. This is the circuit that I'm going to draw here. Okay, V1, V2, V3, V4. I'm going to call this Vn. Okay. This is R1, R2, R3, R4, and I'm going to call this Rn. Okay. Okay. If you check, I have V1, V2, V3, V4. I have R1, R2, R3, R4. Okay, right? And I have Rn and I have what? I have Vn here. I want you to see something. This is a circuit now where these voltage sources are in series with these resistances. Okay, right? This voltage source is in series with this resistor, this voltage source is in series with this resistor, this voltage source is in series with this resistor, this voltage source is in series with this resistor. Same applies to this what? This voltage source. So you see, why am I putting dots now? I'm not sure about the value of it. I can have V5, V6, V7, V8, V9. So it depends with your circuit now. So a circuit can have 10 voltage sources, like up to V10. If you have 12, it means up to what? Up to V12. So this and this is in series, this and this and this are in series. But if you check R1, R2, R3, R4, up to Rn, these resistors are in what? Are in parallel. So Millman's theorem is the same. You can convert this circuit into a simple circuit. You can convert this circuit into a simple circuit, which consists of a single voltage source. So I'm going to draw it here, the equivalent, Millman's equivalent circuit. Millman's equivalent circuit. Okay. So this is the single voltage source, positive, negative here. I'm going to call this is the single voltage source. And here, and a what? A resistance, a resistor in series to the what? To the voltage source. So this is the resistor. This, okay, oh, let me draw it here. Yes. Likewise, you can convert this big circuit into this simple what? Circuit. This is the single voltage source, and this is the what? This is the resistance. Okay, this is very important. So how are we going to get this voltage, and how are we going to get this R? See now, this R is nothing but the total resistance. The total what? Resistance. These resistors are in parallel. So 1 by R is equal to 1 by R1 plus 1 by R2 plus 1 by R3 plus I have 1 by R4 here plus dot plus 1 by R what? N. Okay, wow. Now if you want to find the value of R, you take the reciprocal of this answer. In order for you to calculate this R, this is nothing but 1 by R is equal to 1 by R1, 1 by R2, plus 1 by R3, 1 by R4, plus dot dot dot, plus 1 by Rn. Okay, in order for you to find R now, you take the reciprocal of your answer. How to find this voltage? See, in order for you to calculate this voltage, this V is equal to, this V is nothing but the sum of the branch currents. The sum of the branch what? Currents. See, you have V1, you have R1. You can calculate the branch current here. You have V2 and R2 now. You can calculate the branch current here. V3 and R3 here now. You can calculate the branch current. No. You have voltage and resistance. In order for you to find out the current, what are you supposed to do? V is equal to IR. So I is equal to V divided by R. Likewise, this is how we are going to get the voltage. So you add up the currents. So V is equal to the summation of the branch currents. Summation of the branch currents. Actually, the branch currents now is up to IN. It's up to IN. So up to IN from N is equal to 1 up to N. Yes. From N is equal to 1 up to N. Divided by what? Divided by what we call the admittance now, which is the reciprocal of the what? The reciprocal of the resistance. Okay, the resistances. So this is nothing but 1 by R1 plus 1 by R2 plus 1 by R3 plus 1 by R4 plus dot 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 plus 1 by Rn. And this can also be written in terms of this summation. So if you are writing this in terms of summation, it will be what? This is nothing but you write the summation from N is equal to 1 up to N of 1 by Rn. Okay, of 1 by Rn. So to calculate the value of V is the summation of the branch currents divided by the resistances. Divided by the resistances. Now we want to solve this problem. Using Millman's theorem, find the current through the load resistance RL in the circuit in the diagram below. Also find the voltage drop across RL. You are supposed to find the voltage drop across RL. I said, see, this is the voltage source and this is the resistor. This is the voltage source and this is the resistor. Voltage source and this is they are in series. This and this and series, this and this and series, this and this and series. But this and this and this and this are in parallel. Also the voltage sources are in what? In parallel. So what are we going to do? In order for you to calculate the total resistance, okay, in order for you to calculate the total resistance, 1 by R, let me say 1 by RT is equal to 1 by 4 plus 1 by 4 plus 1 by 4. Okay, and what is the answer here? The answer is 3 by 4. Okay, now you have 3 by 4. What is the value of RT? RT is equal to 4 by 3 ohms. You take the reciprocal. So RT is equal to 4 divided by 3 ohms. Now we want to find the voltage drop across the RL. Okay, now I have the 1 by RT. So what is the voltage? What is the single voltage? You are supposed to have the single resistance first, which is the total resistance. After the single resistance, which is the total resistance, now calculate the single voltage source. So the single voltage source, I'm going to use capital letter V. So capital letter V is equal to the sum of the what? The sum of the currents, the branch currents. So how to find the current now? Current is equal to V divided by what? V divided by R. Here V is 4. Divided by what? By R, it's 4. Okay, and here, what is this? The current here is what? The voltage here is what? Is 2. Divided by what? By 4. And here is what? Is 10. Divided by what? By 4. See, you are supposed to assign the direction of the currents in the branch. See, I'm going to assign the direction of the currents like this. Here, this is I. Okay, I'm going to call it I1, and this is I2, and this is I3. Okay, check this. This I1 is flowing from negative to positive. This is negative to positive, which is nothing but a what? A drop. So this is a drop. Here again, it's negative to positive. See, I think I made a mistake here. If you are moving from negative to positive, what's that? This is a rise now. And you are moving from negative to positive, this is a rise. But from positive to negative, what is this? This is nothing but a what? This is nothing but a drop. So see what I want to do actually, I want to make these ones to be negative and this one to be positive. But even if you do this, still it's okay. Okay, still it will be fine. So I'm going to say my current is going up. My current is going up. My current is going up. So if it's going up, this is going to become negative because this is positive to negative, which is a drop. Positive to negative, which is a drop. And here, positive, this is negative to positive, which is a what? Which is a rise. Plus, divided by. Now what are you supposed to do? The summation of the admittances. Okay, the reciprocal of the resistances. So 1 divided by 4 plus 1 divided by 4 plus 1 divided by 4. Okay, so what is the answer? You do the calculation using your calculator. This is negative 1 minus 0.5 plus 2.5, okay, is equal to 1 divided by, what's this? This is 3 divided by 4. So it's divided by 3 divided by 4, which is 4 by 3. Again, I'm getting 4 by 3 volts. Okay, I have 4 by 3 volts. So see, this is the second now. Plus, minus. Okay. This is